Welcome again to another episode of the Empower Apps Show. I'm your host, Leo Dion. You can find me on Twitter at LeoGDion and my company at BrightDigit at brightdigit.com. I would appreciate if you have really enjoyed this podcast to let me know on social media, but also on Apple Podcasts or whatever podcast player you use. I would love to have some reviews and suggestions. And if you have any feedback for me, feel free to reach out to me on Twitter as well. We have a really great episode today. I'm really excited to have Kevin Scott on the show. Hey, Kevin, how you doing?
Hello. Happy to be here.
Glad you are here. Kevin, what is your expertise?
So I have a background as a designer and primarily a UX designer with a JavaScript background. The past couple of years, I've been mainly consulting with front-end web development with some UX design thrown in there. Recently, I've been getting really involved in the AI community, looking for ways to apply that both to my clients' work and also to my personal work that I'm doing as well, and looking for ways that I can sort of leverage my design background to do that.
So we hear a lot about machine learning quite a bit. Like, I think VCs love it when somebody says machine learning. They want to toss money into it. And specifically artificial intelligence. So maybe first, what's the differentiation between artificial intelligence and machine learning?
Great question. I would describe machine learning as a subset of AI. AI can mean a lot of things. It's not a super precise term. Some people, think of statistics on steroids. Other people sort of think of Skynet trying to take over the world. I don't really personally describe it as AI in the work that I do. I like to use machine learning or deep learning, or even better, describe the things that you're building like neural networks. Machine learning, I would describe it as the technique of teaching machines to make predictions based on data. And you can sort of apply that in a number of different ways and in a number of really interesting use cases. So for instance, very obviously, you may give it a spreadsheet of data and ask it to find patterns or insights in the data. But you can go a lot further and you can say, give it a bunch of photos and tell it classify these photos, or a bunch of different sound files and classify these sounds, or text. And you can even take it further and do things like use the predictions that a neural network will make to synthesize new data. So you might be able to say, you've trained the neural network to basically predict what a human face can look like. You can then take that a step further and say, well, just then give me the output of that and generate human faces for me. And so fundamentally, it is, I think, the act of making predictions at scale, but the applications for that are extremely varied and wide. I think people get tripped up around thinking that these machines have any agency. We are not yet at the point where computers have any sort of inherent intelligence. They're not deciding these things for themselves. I think a good way to describe it is statistics on steroids. At the core, these are just mathematical functions that are being executed at mind-boggling scales. And an emergent property of that is the ability to mimic human behavior in a number of very specific areas.
Our sponsor this week is BrightDigit. BrightDigit is my company, and we specialize in helping businesses build apps for the iPhone, the iPad, the Apple Watch, and the Mac. I've been building apps for iOS for almost 10 years now. We have an opening for new projects. If you are a company who might already have developers but need help building something for any of the Apple platforms, send me an email and let's see what BrightDigit can do for you. Contact me personally at leo@brightdigit.com. That's leo@brightdigit.com. And let's see how I can help you and your business. I feel like machine learning is one of those buzzwords that gets tossed around a lot. It's a tool that people use for everything, but it's not necessarily useful in all cases. What are some big mistakes where people think that machine learning is a good fit, but it might not be?
Well, I think that the field has made a number of large strides, especially in the past 5 years. But one thing that remains true is that you need a significant amount of data to make it work well. And so I think a lot of the time, companies, they don't have a good idea of what their data is, what's in their data, how it's stored, what insights they can get just from normal statistical methods on that data. And so I think there's a lot of hype around these technologies, but for a company entering the space, a good first step is to sort of do an audit of what is the data that you currently have and how is it organized. And there's often some really low-hanging fruit that you can get as a result of that process.
What's an example of like low-hanging fruit that you could use? Because even like, if we even take out machine learning from the equation, I don't know how many times I've had a development project where the Excel spreadsheet or the CSV file I've been given is filled with a ton of garbage that needs to be cleaned up before even putting into a SQL database. So I can imagine like machine learning is going to even be more strict than that.
There's a funny quote by the founder of Kaggle that 80% of data science is cleaning the data, 20% is complaining about cleaning the data. So it doesn't surprise me that that's been your experience. Yeah, I mean, I think I don't want to get too into specifics because I feel like it kind of depends on your industry. You know, healthcare is going to be very different from, say, like the insurance industry in terms of the insights that you can get. But I think it's a good exercise just to get familiar with the data that you have. Like data cleaning, it's not, I think, hyperbole to say like it takes a massive amount of time. And it doesn't make sense to enter into some data science project until you have a good idea of what you're dealing with, because you might have a set of ideas or a set of predictions that you want to get to that are not even possible without understanding how your data is organized and how messy it is. So I think that there are just basic understandings, I guess, of how your data is organized is an important first step before diving too far into this stuff.
So let's talk a little bit about that data, because it seems like there's different types of machine learning or different categories of machine learning, depending on what kind of data you're given, right?
Yeah. So I guess I should caveat what I just said by bringing up this technique of something called transfer learning, which is a technique that has gotten a lot of uptake recently. So you asked, what are the different kinds of data? So I think so far I've been mostly talking about structured data. So for instance, data in an Excel spreadsheet. Other kinds of data like image data or sound data or text data are, I think, more amenable to having insights from neural networks. Whereas a lot of that structured data, you can use more classical machine learning methods and just regular statistics to pull out insights. But some of the more fancy hype train kind of techniques really shine when it comes to rich data like images and text. And one of the really valuable techniques that has picked up steam recently is this idea of transfer learning, where you take a neural network that's been trained on a massive corpus of data and you just sort of fine tune the end of it on your specific use case. And so a popular example might be there is a neural network put out by Google called MobileNet. You can download it for free. It's trained on, I think, 1 million images or some large number of images. And what you can do is pull it down and give it a very small number of images of your data set. So let's say I want to be able to detect different sports. Let's say I want to detect cricket from rugby or something like that. I could give it as few as 10 images per class, and it would be capable of then returning a classification after having just been fine-tuned on that smaller data set.
Are we talking about photos here?
Yes, photos.
Okay.
Yeah.
All right.
There has been a number of new, over the past year, in the text world, very similar advancements have been made. If you've heard of OpenAI, they put out this neural network called GPT-2, which has gotten a lot of uptake. I think it's trained on Wikipedia. And so you can do the same thing where you can fine tune it on your own text corpus, and it will generate text in the style of whatever you give it with much less training.
What exactly is a neural network? Maybe explain that a little bit.
Yeah, sure. A neural network, so it's made of neurons. You may be surprised to learn. It's made up of these building blocks called neurons. And a neuron, it's modeled after the human brain, but the similarities kind of end there. A neuron is basically just a mathematical function. It takes a number, transforms that number in some way, and spits out another number. A number of these neurons are combined into what's called a layer, which you can think of as horizontal. So imagine like you have 1,000 neurons in a single layer, and then you have vertically anywhere from 1 to hundreds, maybe even thousands of layers. So very quickly you get to these very large scales of neurons. But fundamentally, all these things are doing is transforming numerical data into some other numerical data.
So is the process of building a neural network is about having the machine figure out what those mathematical transformations are going to be?
Effectively, yes. You generally specify the way in which incoming data is transformed, but then the neural network will learn the weights with which to apply those transformations, if that makes sense.
Yeah, that kind of makes sense. Yeah.
And one of the really interesting things, this may get too mathy, but the way that neural networks are able to model really complex data like images is that they use these mathematical functions that are nonlinear. So for instance, an example might be any number under 0 gets turned into 0, any number over 0 gets let through untransformed. And so what ends up happening is you sort of have these very sort of cliff-like structures of transformation within the neural network that are able to model really complex information going through. If you actually dive into this, I'm like simplifying extremely much, but vaguely that is how these things are working on the inside.
Yeah, I got you. And then like getting into the weeds of it is like figuring out how to train those neural networks or figure out how to do those mathematical transformations.
Yeah. And
we'll provide links in the show notes to that.
Sure.
So we talked about transfer learning. What other types of learning are there?
Well, I mean, traditionally you would train a model from scratch. And, I think if you are doing anything super domain specific, or if you're one of the big companies doing this with a ton of compute resources, I think that's generally how you work. But for smaller folks or hobbyists like myself, it's just not feasible to train GPT-2 from scratch. I think would take me a year on my hardware. It's just not feasible for me to do it. So it's fundamentally it's a shortcut to get a better performing model. You're basically reusing the work that others have done and shared with the community to speed things along. It's like using a third-party library off NPM or something like that.
So I've looked at some different types of ways that Swift specifically builds models. So one thing is like a recommender, for instance, where it looks at someone's history and figures out what movie or book they're going to be interested in. There's, of course, image recognition, which you kind of touched on. And then the other ways of using like data tables as well. What are other types of data most folks are going to be interested in using?
Yeah. Any data that is measurable on an iPhone is a candidate for applying machine learning techniques to. So, for instance, off the top of my head, I could think of accelerometer data. You could train a model that could distinguish between, okay, I'm walking, I'm sitting, I'm biking, I'm driving, just based on how the accelerometer is moving. Other sensors, maybe you could do something with like the light. Do you have access to light sensor? I haven't done iPhone programming in a little while.
No, you have access to the camera though.
Okay. Yeah, I mean, the camera I think is really fascinating. So one of the areas I've been looking a lot into is transforming images. So for instance, on the Pixel, one of their flagship features was low light mode, where you take a photo and it uses machine learning to enhance that photo and appear a lot richer and closer to a daylight photo.
It seems like that's one of the user-facing features I think most people have seen with new iPhones. And it seems like that's one of the most user-facing features with these new iPhones is applying machine learning to photography. And what I've heard the term used is computational photography, where we're looking at like looking at the photo and figuring out like what's the background, what's the foreground, where's the face and things like that. And then I've got obviously like with some of the new low light stuff in the iPhone 11, we see that as well.
Absolutely. Yeah, and I think we're sort of at the cusp of where these technologies are going to go. I mean, I think alternatively you see with Snapchat things like makeup filters or things that will transform your face in some way. Techniques around anti-blurring. You see super resolution is a really interesting one where you take a small photo or a grainy photo and you blow it up to a better resolution. Transforming photos after the fact. I think a few iterations ago on the iPhone, there was a lot of buzz around the bokeh effect. You'd sort of change the focal point of the photo after the fact.
Yeah, with portrait mode.
Yeah, which I think I think they were relying on hardware to do that, but
I think it's both. I think it's the 2 lenses on the camera or 3 lenses.
Okay. I think stuff like that. In the realm of sound, I've seen some really amazing demos from Google that they demoed in Hangouts around background noise. They did this one demo where someone was sitting in a crowded bar and it was as if he was sitting in a silent room. And it's really fascinating how they're training this stuff. They're using a lot of, so actually one of the big problems with a lot of these data sets is how much data you need. And so when you can find a problem that you can use synthetic data for, it sort of opens up the possibilities of what's possible. And so Google went out, they took a bunch of YouTube videos with people talking and they put them side by side and they trained the model to be able to isolate speakers based on the video. And then they were able to use this in Hangouts to basically focus on the person who was talking to the camera and cut out all the background noise around them. So, I think there are a lot of places like that ultimately those are also predictions that the computer is making at, 30 frames a second or whatever. And the difference is instead of numbers in a spreadsheet, you're looking at an incoming sound wave and saying these bits of the sound wave, are irrelevant, let through the voice.
What are some industries where you think that machine learning would be really effective, especially like in an iPhone app?
I mean, a really obvious one is healthcare. I think the challenge there is respecting privacy. There has been some research towards training models without giving them full access to the underlying data set. So basically being able to pull out the insights without actually having access to the data, which I think is compelling, but I'm not sure how far along that is. And it's a big concern, obviously, when it comes to healthcare.
I think the biggest one that we see a lot, at least Apple tries to push, is augmented reality and applying machine learning to that.
Yeah.
That seems like a big place. And then maybe like audio when it comes to, I've seen it producing this show. When it comes to transcription, I've seen AI and machine learning used in that case as well.
Absolutely.
Quite a bit.
Transcription is a really big one.
Yeah. And we'll get into the difference between like client and server, but those are the big on-device ones that I've seen. So let's say somebody wants to like have some sort of visual recognition or a recommendation engine or something like that written. They want to get a model. How do they get their data ready for use in a model to be applied using machine learning?
So it depends on the specific task that you want. If you're doing image classification, I know MLKit provides an out-of-the-box classifier where you would basically organize your images into folders. So you may have, to go back to the sports example, you may have a folder called cricket and a folder called rugby, and you upload those folders into, I think you set up a playground and you drag it in there and it will spit out a trained model for you. You can do the same thing with text. So those are classification problems. Going a step further, you may want to do something like multi-label classification. So instead of labeling rugby cricket, you might say this is a plant and this is a light and this is a person kind of thing. I'm not as familiar with what the Xcode offerings are for that, but I know there's a lot of models. YOLO is a very popular model. It stands for You Only Look Once. There's some very funny names in the AI community. If you're doing object segmentation where you sort of draw an outline around an object, like for instance, I saw a really fun project where someone set up a camera and was able to count the number of cars in a parking lot. And then it would alert him whether the parking lot was full or not before he drove over to this place. I think it was his work. So, basically whether he'll have a parking spot or not. So, I think that where there is a popular architecture, there are likely code snippets available on GitHub of folks who have implemented these. Where those exist, sometimes there are pre-trained models. And if you have a pre-trained model, you're basically, 90% of the way there. If you don't have a pre-trained model, then you have to look at, do you have enough data to train this effectively? And unfortunately, there's not really a sort of rule of thumb for how much is enough. More is always better, but it really depends on the architecture, on the use case. And so at some point, you just sort of have to try and see what the results are and go from there.
So obviously, Swift has Create ML for creating the models and then Core ML for actually using it. What are some other common platforms for building a model?
Sure. Well, I would say a number of startups at the sort of no-code end, a number of startups have pushed workflows that try to abstract out the process of building a model. Sort of going a little more technical, there are things like AWS SageMaker provides a platform for running these models that you design, but then you just sort of need that extra compute to make it go. And then all the way to the other end where you sort of do everything yourself. As far as languages, Python is the most popular. I don't know, by far. Other contenders are the language R and Julia are also fairly popular. Swift has, through Xcode, Swift has a lot of tools for making this go. But interestingly, a lot of people are looking at Swift as a server-side language to do machine learning. That is very much in its infancy, I think, like maybe the past couple years. But some really good thinkers are looking at Swift as a great platform for doing that. Because of my background as a JavaScript developer, I actually do a lot of machine learning in JavaScript using TensorFlow.js. Plug for myself, I wrote a book on such a topic. And it's a really fascinating platform because, getting into it, I thought there's no way we can do this stuff in the browser. But with transfer learning and the sort of advancements with WebGL, you can actually do you can use a tremendous amount of these techniques in the browser. So, I think you can do ML across a wide variety of platforms in a wide variety of different ways. And I would say there are best practices that people subscribe to, but it feels like a sort of Cambrian explosion at the moment. Like everyone is sort of experimenting and doing different things, and there's not yet like the one true way that you do this stuff, which is, I think, really exciting. And it's a really exciting time to get involved in the field and sort of contribute to that, especially as someone with more of a design engineering background, looking at ways to like standardize and settle on best practices is really exciting.
So when you're using an iPhone app, where have you felt like, why aren't they using machine learning in this case? Where do you think like current apps that don't implement machine learning could have use some sort of model to make the experience a lot more enjoyable and easy to use?
Yeah, I think anytime you're dealing with rich data like images or audio, those make really good candidates for looking at ML techniques. So for instance, let's say you're building an app that does audio memos. Maybe you can automatically, so we brought up transcription. Maybe you also automatically annotate the recording, maybe split it at points where it feels like these should be separate audio files. That's something that can definitely be done with ML on the device. I think that it gets into this discussion of server versus client, which is sort of a larger discussion around what ML do you do on device and what do you do on a server. And there's sort of different use cases for that. Doing it on the device, I think, has a lot of important things to recommend it. For instance, privacy. You're not sending data to a server. Latency. If you're doing anything, let's say you're dealing with audio, real-time audio, you may if you're like, or if you're doing something like 30 frames a second, you don't want to be sending information up and down the pipe. Bandwidth might be a concern too, especially on mobile. So things like that, I think, are very compelling for running on device. And again, with transfer learning, I think those are use cases where it can be very effective. I think if you're doing more sort of analysis after the fact type processing, it still makes sense to do that on the server, just because you have more compute power. So for instance, let's say you're building like a photo album and you want to take the images and sort of analyze them for picture. Like if you've ever used Google Photos and you can search by like an object, I want to look for outdoor scenes. I think that sort of processing makes sense to do on the server more than on the device, just because of the sort of compute needed for that. So I think there's a lot of opportunities. I think the most obvious contenders are anything that deals with image or audio. Text is still a little bit more challenging to deal with, especially on the device, but there's a lot of progress being made in that area. And I would not be surprised if 2020 continues that trend.
And when you say text, you're talking about like, one thing I've seen a lot of is like trying to figure out the mood of someone based on like their Amazon reviews or something like that. Is that what you're talking about?
Yes, absolutely. And I know Create ML does text classification. So I think that specific use case you can do, but I'm not sure what the state of, say, like predictive text is. If someone is typing and you want to be able to predict the next thing that they're going to write, I think generally something like that has been done on the server. So I'm not sure, but something like that I think would also be a great candidate come this year or maybe 2021 in terms of what's available in terms of compute.
Yeah, one thing I've started looking at is actually doing ML on the server. There was a great Fritz AI tutorial about implementing machine learning with Vapor, which I find really fascinating. And, Apple's big emphasis is doing stuff on the device, both because their devices are really powerful, quite frankly, but also because of the privacy concerns. So that's one thing I've seen is like, I think there are some stuff, especially with some security, you can do a lot on the server as opposed to a lot on the client. Are there ways of like perhaps doing like a hybrid of both so that way privacy is not a concern?
Absolutely. I mean, the sky is the limit. A lot of these techniques can equally be done on the client or server. So for instance, image classification, you could upload it to a server and classify it there, or you could do it on the device, and it's really up to you. I think the only sort of limitation is how much compute power does the inference portion, the prediction portion of the model take.
Okay.
And often it's not very much, but it really depends on the data set and the actual model itself.
Gotcha.
Usually, training is generally, I would say, almost exclusively done on the server. There are some places where that's not true. For instance, if you're like fine-tuning a pre-trained model, you can do that, say, in the browser. But generally, if you're training anything significantly large, you would do that on the server.
One thing I wanted to ask is, let's say you are building your own model. And one of the issues that I've run into is not knowing how much data I need in order to do that and how to get that data. So first of all, how much data do you need to sufficiently build a really good model?
Unfortunately, there is not a good answer to that other than it depends. I think, for instance, if you are doing an image classification model that's trained on MobileNet, you can get by with 20 images. If you're, training a text generation model from scratch, you might need 100 gigs of text. It is very, very wide in terms of what is potentially out there. What I generally do is look for examples that other people have done in the area. So let's say I'm doing something with audio. Let's say I'm doing audio classification. I may go out and see what models are popular and what were they trained on to get their results. And that sort of gives you a benchmark for what the sort of state of the art is looking at. And then I think a good subsequent technique is to then pull their training code and try it on whatever data you have. So, if you only have 1,000 examples, give it a go, see what the output is like. And then, it's sort of up to you whether that amount of accuracy is going to fit your problem set.
Is there a good way to create data if you need more?
So that's called synthetic data. And that's what Google was doing when they were training the Google Hangouts to be able to identify speakers' voices. They went to YouTube and basically took a bunch of videos and combined them into synthetic data sets. So you can do that. There's also, I think we're at the cusp of startups beginning to offer synthetic data as a service. So for instance, if you need, say, certain images, they can generate those images on the fly for you within certain parameters. I think the problem with some of this synthetic data is sort of like one of the things you need to be wary of is that you are training your model on the same data that you expect users to give it. And so
it seems like you'd create a feedback loop.
You generally do. I mean, it's a big issue. And also, machines are very sensitive to things that might not seem like a big deal to you or I. Like, for instance, if you have two photos and one is slightly brighter than the other, the machine may interpret that as a fundamentally different photo, whereas to you and me, they look identical.
Right.
And so one of the challenges with synthetic data is making sure that that is not tripping up your model. So for instance, there may be artifacts in the synthetic data that then the model learns to expect. And then your users will upload photos and they won't have those artifacts because they're not synthetic. So it can be a challenge. I think it is worth looking at as a supplementary technique, but it's not a silver bullet. There's other things too, like data augmentation. A common thing when, say, doing image classification is to flip the images or rotate them slightly or compress them in different ways, basically augment the data set that you have with additional photos.
How about something like Google image search? Like if you're searching for a specific type of objects and just using the images that you find off of Google Images, is that sufficient?
Yes. Well, again, it depends on the problem. So are you using a pre-trained neural network to do image classification? If so, then yeah, you can get by with 20 images that you find off Google Images. If you're training from scratch, you might need 1 million images.
Okay.
You also have to make sure that the images that you're getting from Google Images are curated so that you don't just type, give me all the images of cricket, and then half the images are actually the insect cricket instead of the sport. It makes intuitive sense, but that's really hard to do at scale. If you're dealing with 1 million images, very few people have the time to step through each of those images and make sure that they're valid. Now, maybe you can train a neural network to do that, but then you're really getting into Inception at this point.
Awesome. So before we close out, I wanted to ask, where have you seen machine learning applied where it really doesn't belong? Or what are some limitations that you see machine learning running into, especially in the next few years?
So I think that we've seen really huge increases in compute power, both in terms of the server and also consumer devices, seen huge speed ups. And that has traditionally been a problem that is going away. I think we've seen major research advances this past decade that have sort of unlocked new capabilities, which has been really exciting. I think what remains an issue is data. In a lot of cases, we have yet to figure out how to build robust models without first feeding it a ton of data. And I think there's a lot of people working on that problem, but it is unsolved yet. And I would say another problem is that the UX, and by that I mean sort of the developer UX, the way that we build these things and interact with them, is still very sort of primordial, soupy. We're very much in the early days, and I think we're going to see a lot more progress in that area. I think Apple has done a great job with Xcode, with Create ML. I think there's a lot more work to be done in that area, just making these things more intuitive for developers to understand and interact with and build. It's a tricky problem because you need to understand at a low level what's going on to debug effectively, but most of your time is not spent there, which can be a very challenging thing where you might spend 90% of your time collecting data and cleaning data and getting it into the right format and formulating the right questions to ask. But then if you don't have that final 10% to really understand the internals, it falls apart. And so I think the more that we begin to sort of standardize on best practices, I think we're just sort of touching the surface of where these things are applicable. I think, if it was as easy as integrating a third-party component, with one line of code, I think we could see neural networks sort of applied to almost everything in an app or on a website. There's very few use cases where they wouldn't be beneficial. It's just that they're so damn hard to work with today that I think we need to do a better job of making them easy to understand and work with.
It's almost like you're suggesting there's room for abstraction in the process of creating a model and building an app that makes that user experience when it comes to model creation and getting machine learning up and running. There's almost like a need for that. And
absolutely,
there will be probably something in the next few years from the developer community to make that process a lot easier.
Absolutely. I think there absolutely will be. I think that's going to be one of the big stories of this next decade.
Almost like the natural progression from going from the terminal to the GUI. It's there are things that you don't need to see when you're building a model 90% of the time. A lot of tweaking can be done in a GUI interface as opposed to just a massive text file, so to speak.
Absolutely.
Cool. Thank you so much, Kevin, for coming on the show. Where can people find you?
You can find me at my personal blog, thekevinscott.com. I'm also at Twitter at the same handle, thekevinscott, or on GitHub at the same handle. That's my handle. You can find me anywhere on the internet. I also have a book, Deep Learning with JavaScript, dljsbook.com. And feel free to reach out with any questions. I'm happy to. I love this stuff. I think it's some of the most fascinating technology I've encountered so far in my professional life. So I'm always happy to talk shop.
Awesome. Well, thanks for coming on, Kevin.
Absolutely. Thanks for having me, Leo.
People can find me on Twitter at LeoGDion or my company at brightdigit.com. If you have any questions, let me know. I look forward to hearing any feedback or questions you have about machine learning and Swift that you'd like us to cover in a future episode. Thanks again for joining us on this show.